Hi friends, I am Suresh Kumar. My channel name is San Suresh Kumar. Today topic is how to answer bond order related questions part 4. This is the continuation of part 3 video. If you are new to this video, please watch my part 3 video. In part 3 video, I have shown you bond order, how to calculate bond order and its application in bond length, bond strength, bond dissociation energy, bond stability, IR stretching frequency, magnetic properties. Okay, and I shown the relationship between these. Bond length is inversely proportional to bond order, bond strength is directly proportional to bond order, bond dissociation energy or bond energy is directly proportional to bond order, bond stability is directly proportional to bond order, IR stretching frequency is directly proportional to bond order, and magnetic properties and molecular electronic configuration for up to 14 electrons arrangement and more than 14 electrons arrangements we have studied yesterday, previous video part 3. If you didn't watch, please watch the video part 3. And we discussed about the p orbital arrangements. So the p orbital arrangement only the varying for up to 14 electron molecules or ions and more than 14 electrons. This is the arrangements of p orbitals in up to 14 electron system and molecules or ions. This is arrangement for the more than 14 electrons. This comes under the symmetrical arrangement. You can see the orbitals filling. This comes under the bonding orbital. This is the anti-bonding orbitals. This is the anti-bonding bonding orbital, and this is the anti-bonding molecular orbitals. You can see the symmetrical arrangements in here, but here there is no symmetrical arrangement. So this more than 14 electrons electronic configuration we call symmetrical arrangement, but in 14 up to 14 electron system this is not a symmetrical arrangement, so we call it as a asymmetrical arrangement. So we saw the trick for bond order up to 20 electrons system. So I show how to draw this bond order trick, so you may try this in your notebook. If you forget this, you can just remember for 14 electron system, for 14 electron system the bond order is 3. Less than 14 you can reduce 0.5, so it's 3, 2.5, 2.0, 1.5, 1.0, 0.5, 0. More than 14 you can reduce 0.5 minus 0.5, 3.0, 2.5, 2.0, 1.5, 1.0, 0.5, 0. So like then you can remember for your examination. Okay. Using this trick, we have solved 3 questions in part 3 video. Today I am going to explain few more tricky questions asked in some examinations. If you understand the concept behind these questions, you can solve these type of questions in your exam, in your next examination. Okay, watch the video up to the end. I hope you will learn something new. I will show you how to approach these type of questions. Okay, let us move to the today's topic. So first question: 4 diatomic species are listed below. Identify the correct order in which the bond order is increasing in them. So if they ask bond order, first we mark bond order, then we mark the increasing order or decreasing order. Okay, so whenever you see the bond order question, you just remember our trick. First draw our trick, then we move to the calculation. Okay, so first you draw one small line, then draw 2 triangles, then bigger one. Okay, then draw a line like this. 2, 3 and 4. Okay, then starts from here. So this 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. For 0, 4, 8, 20, bond order is 0. For 1, 3, 5, 7, 9, 19, total electron system 0.5 bond order. For 8, 18, 10, 6, 2, bond order is 1.0. 11, 17, bond order 1.5. 12 and 16, bond order 2.0. 13 and 15, bond order is 2.5. And 14, bond order is 3.0. Okay, now we need to calculate the total energy, total electrons in the given molecule or ions. So first start with the helium ion. Okay, helium He2 plus. Okay, so before that we need to know the periodic table, basic S block and P block. Then we can easily identify the total electrons present in the molecules or ions. For hydrogen is come here, helium right here, hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. Okay, just you remember this and we can calculate the total electrons for helium. O2 minus NO C2 2 minus. Okay, for helium 2 heliums are there, 2 into helium O2 bond order 2, total electrons 2. If the sign is positive, 1 electron is removed, so 4 minus 1 equal to 3 electrons. Okay, for O2 minus 2 oxygen, so 2 into oxygen, so that's 8 minus sign plus 1 electron, so 8 into 2 16 plus 1 17 electron. Okay, nitrogen oxygen 7, oxygen 8, 7 plus 8 15 electron. C2 2 minus 2 carbon, 2 into carbon 6, carbon have 6 electrons, and plus 2 negative, so 2 plus 2 electrons, so 60 plus 6 into 2 12 plus 4 14 electron. Okay, so now we know the total electrons. Based on the total electrons we can identify the bond energy, bond order. So bond order for 2 electrons, 200 electrons, so 0.5. Bond order is 0.5 for 3 total electrons species. For 17 electrons, so O2 minus 17 electrons, so 1.5 here. For 15, the bond order is 2.5. For 14, 3.0. For 14, 3.0. Based on this, we can arrange He2 plus He2 plus is greater than less than 2 minus this NO have higher bond order, this C2 2 minus have higher order. So this arrangements comes in the option number 1. So the option number 1 is right. Next, according to the molecular orbital theory, which of the following list ranks the nitrogen species in terms of increasing bond order? So here they ask increasing bond order and they give the rank for nitrogen species. Okay, so we know nitrogen has the bond order is 3. So based on the trick, we can directly answer this option. We can shout out this and this. For other species we can't directly answer, so we need to calculate the total electron for others. So nitrogen, we know they give nitrogen n2 minus n2 2 minus. For nitrogen so we know bond order is 3. So always remember this, for nitrogen bond order 3, because nitrogen the bond triple bond n. So the bond order is bond length, bond number of bond is directly proportional to bond order. Number of bond is directly proportional to bond order. So number bond order for nitrogen is 3. So then we can calculate nitrogen n minus. So n minus, so 3 for neutral species, this is negative species. So 3 for negative we add 1 electron. So sorry, for nitrogen 14 electron system, so you calculate nitrogen 14. Here 14 plus 1 electron, so 15 electron species. n to 2 minus 14, neutral 14 electron, this comes under 14 electron, 14 plus 2 electron, so total electrons are 16 electron. For 14 bond order is 3.0. For 15 we know the trick. For 15 so 2.5, 2.5. For 16 2.0. So based on this we can arrange n2 greater than n2 minus greater than n2 2 minus. But they ask the increasing order, this is the decreasing order. So based on the option we can answer n2 2 minus is less than n2 minus less than n2. Okay, this is the way of answering the question. Okay, you can see next question. Identify the correct pair have same bond order. So here they ask the pair have the same bond order. So pair same bond order, so they give the pairs. So the pair is nothing but the isoelectronic. Isoelectronic means the total electrons are same. Total electrons are same. Sometimes they ask the question like that only. So identify the isoelectronic species from the option. So we can answer like that only. So we know what to do. First step, we need to calculate the total electrons. So first option O2. So O2 oxygen 2 into 8, 16 electron. Nitrogen n2 plus 2 into 7 minus 1 plus plus, so 14 minus 1, 13 electron. Option 2. So these are different total electrons, so this is the not correct answer. Second, O2 2 plus O2 2 plus 2 into 8 minus 2, because 2 plus electrons, so minus 2. 16 minus 2 equal to 14 electron. 14 electron. Nitrogen neutral species n2, we know 2 into 7 is equal to 14 electron. So they ask isoelectronic or pair have same bond order. So these two have the same total number of electrons, so both have the same bond order 3, isn't it? Bond order 3 for this. We can check the other option. NO. For NO, nitrogen 7, oxygen 8. So total number of electrons 15 electrons. CO, carbon monoxide, carbon 6, oxygen 8. The total electron is 14 electrons. So these are not here. Both are not equal. So this is not isoelectronic. Next, nitrogen. We already know nitrogen have 14 electrons. NO here 15 electrons. So both are not equal. So option is not correct. So the correct option is option 2. So option 2 is correct answer. Next, which of the following pair of species have the same bond order? Here also the same type question. Pair, same bond order, the same type. They are isoelectronic species. Isoelectronic. Okay, same. First start with the option number 1, carbon monoxide. We already studied. So the carbon monoxide total electron is 14 electron. Nitrogen oxide NO is 15 electron. So the option 1 is not correct. Then 2 O2. So total electrons for oxygen 16 electron. NO plus we can calculate 15 minus 1 because plus 1, so 14 electron. Option 3, Cn minus carbon 6, nitrogen 7, negative charge, so plus 1, so 7 plus 7, 14 electron. CO, carbon monoxide, we already calculated 14 electron. So both have same. Option 4, we can check option 4, N2, nitrogen 14 electron, oxygen O2 minus, oxygen 16 plus 1 negative charge, so 17 electron. So both are not equal. So the option 3 is correct answer. So option 3 is correct answer. So you can answer like this. Isoelectronic or pair they give. Okay, based on that we can directly answer. So no need to calculate the bond order. Okay, so we can check the other type. Which of the following order is correct for the bond dissociation energy? So this is the different pattern. Dissociation, bond dissociation energy of O2 2 plus, O2 minus and O2 2 minus. Okay, so we need to calculate the total electrons for the species. So I get 2 oxygen O2 plus, O2 minus, O2 2 minus. Okay, for oxygen 16 electron, O2 minus, O2 2 plus, O2 plus 16 minus 1 plus means minus 1 electron, 15 electron. O2 minus 16 plus 1 electron, so sign is minus, so 17 electron. For O2 2 minus 16 plus 2, 18 electron. Okay, so based on this we know the bond order for this 14, 3, 15, 2.5, 16, 2.0, 17, 1.5, 18, 1.0. Okay, up to 18 we can use. So here 18, 1.0, bond order is 1.0, 17, 1.5, 15, 2.5, for 16, 2.0. So based on this we can arrange this by 1, 2, 3, 4. Okay, based on this, first O2 plus then O2, then O2 minus, then O2 2 minus. Okay, I hope you understood. Sometimes they mix these signs. Don't confuse, don't check, don't see the options, just work out the bond order, then you can arrange, then you can identify the option. Option 1 is the same arrangement, so you can tick option 1 is the right answer. Okay, then bond order of helium and helium plus R. So this is one of the trickiest question. So this is a symbol, but some people do mistakes in their exams. They worried about this half during the examination. So every trick they use only the fractions, but here they use the 1.1 divided by 2, 1 divided by 2. So some people get afraid of these signs. Okay, for helium, so 2 into 2, total electron is equal to, total electron is 4 electrons. Helium plus 2 into 2 minus 1, because sign is 1, and it is this 4 minus 1, 3. Okay, based on this we can calculate. So we need to check our trick. 0 1 0 1 2 3 4 5 6 7 8 0 0 0.5 1 0 0.5 for 3 4 0.5 6. For here 4.0, the bond order is 0. Bond order is 0 for, bond order is 0 for 4 electron systems or molecules or ions. 2 electrons is 0.5. 0.5 is nothing but 1 by 2. Okay, you can click the check the, you can tick the option number 1. I hope you can understand this. I will continue my other questions in next video. Thank you.